Okay, we went through coterminal angles worksheet on Friday. That's what we did. If you were not here, then I need to get you one by the end of class. Somebody said they lost their notes. Was that you? Oh, you got your notes. Anna lost your notes. I have a packet for you. It's my notes for today too, so if I make a mistake. You lost notes too? No, you got them. Okay. So here we go. Angular speed, omega, equals theta divided by time. Now, we use omega. What are you laughing at? Say it. So you're laughing first hour too, and I don't know why it was. Just say it. Laughing. All right, okay, here we go. All right, so theta is rotation in radians. And this is time, and it's usually in seconds. Not always, but usually. Okay? So, for example, it's kind of like this. If I'm on a, what do they call those things at the park? They spin around and you hold on to them. Merry-go-round. Okay, if I'm on a merry-go-round, the question is, how fast are the angles turning? So, like, if I have a circle, and we would say, well, that's like 1 radian, that's 2, that's 3, that's 4, that's 5, that's 6. Okay, how many radians do I turn in 1 second? Do I turn 1 radian, 2 radians? How fast is it turning? It doesn't mean this. Let's say that Danny is hanging on the end of it. We'll draw 2 arms ahead, and oh, this is really bad. There you go. Danny's just hanging on for dear life. That doesn't mean that he is traveling at that speed. That means that it's covering that many radians, and that's what's happening. Okay. So we'll do an example here in a second, but linear speed, what we say is velocity is equal to s divided by t. And s, remember, we define as s equals r theta, meaning the distance around. So if you actually wanted to find out, okay, Danny's hanging on to the end and he's flying around, how fast is Danny actually traveling? Well, yeah, you would have to figure out s by doing r times theta and then dividing it by time. But we can actually make a nicer formula for volume by expressing a certain relationship. For example, does everybody see here that we've already stated s equals r theta? Everybody know where that came from? A couple days ago we talked about that. So arc length is r times theta. And we also know this. If I multiply both sides by t, I get t equals, t omega equals theta, and then you divide both sides by omega, you get t equals theta over omega. So we've got t equals theta over omega. Now let's see what happens when I go back to this formula. Velocity equals, instead of s, I can write r theta over 1, I'm going to write, divided by, what can I write t as? Theta over omega. Now, instead of dividing, I can multiply by the reciprocal. What happens? Those cancel, and so you get velocity is equal to r omega. Which is really nice because, you know, a lot of times you want to figure out the angular speed. And instead of having to figure out what s is, we just take the radius and we times it by omega, and we get our velocity. So that would tell us, you know, if Danny is going to be able to hold on or not, or if he's just going to fly off. We hope you would be okay either way, Danny. All right, so a bicycle wheel that's 24 inches in diameter rotates 100 rotations per minute Find the angular and linear speed. Angular and linear. I'm sorry if I'm going fast today, but I'm just trying to fit this whole lesson in. So if you need me to stop or something, just go ahead and raise your hand, okay? Angular speed is omega equals theta over time. In this problem, what is theta? Any idea? What is one full rotation in radians? 2 pi. 2 pi is one full rotation. How many rotations do I make? 100. So if I make 100 rotations and each one's 2 pi, what's that total angle measure? 200 pi. Is anybody confused how I came up with 200 pi? 100 times my 2 pi. Always going to be times 2 pi. Divided by time. Let's convert this to seconds. So how many seconds is it? Rotations per minute, so 60 seconds. Somebody grab a calculator. 200 pi times 60. Or 200 pi divided by 60. What's 200 pi divided by 60? Somebody with a handy-dandy calculator. What do you got? You're close. 1047? 10.47 radians per second. See it? Now, if I want to find the linear speed, all I have to do is say velocity is equal to r times omega. And you know what omega is? Omega is 10.47. So we get velocity is equal to r, what's the radius? 12 times 10.47. So we got 12 times 10.47. What you got? And that's velocity, so I should really have a label. Feet, inches, centimeters, what do I got? Inches per second. So speed is, or velocity is always going to be, you know, a distance divided by time. Yes, one is incorrect, the other is incorrect. Any questions? Got it? Paddle wheel has a radius of 0.3 meters and rotates 80 rotations per minute. Find the speed of the current in meters per second. So instead of going straight to the speed, let's first find the angular speed. Angular speed is going to be omega equals theta divided by time. What's theta? $160 pi divided by, it looks like it's per minute, so I got to convert to seconds, so I go 60. What if it was rotations per second? What would you put on the bottom? 1. It's just 1 second in a second. So, okay. 160 pi divided by 60. 8.4. Radians per second. So I'm going to transfer that into linear speed. Find out the current, which is pushing the paddle wheel. And I know that velocity is equal to r. What's r? 0.3 times omega, which is 8.4. 2.52. Give me a label. Meters per second. 2.52 meters per second. Cool. All right, flip it over. Any questions on that? All right, we start the new section. I had such a sad day the other day. I was on Facebook like once every 3 months. I go on Facebook. I had a birthday and everybody was wishing me happy birthday. But then about a month later, somebody sent me a picture. There's a picture from camp. It brought back such good memories. Everybody kept writing me and commenting about this picture. It was great. For my day I left camp, they gave me like I'm not kidding, 12 cases of Mountain Dew, and they had them all stacked up in a huge pyramid. It was like as tall as I was. Anyway, they all called me KG, and I realized that I don't ever get called my nickname anymore. I always get Mr. G or Mr. Gens or Gens, and that's all you call me, right? It's kind of sad. Well, no, I don't want you to call me KG. You're a student. But there was like 12 years of my life where that's all I was known by. Yeah. Kind of like Kevin Garnett. They have similar characteristics. All right. Okay. Sine of theta. Write this down. SOHCAHTOA. I never learned SOHCAHTOA, and my life was fine. Here's how I learned it. I said sine of theta is y over r. Cosine of theta is x over r. Tangent of theta is y over x. And then these are the reciprocals. And my life was fine and still is fine. That's the way I always think of it all the time. But you guys, some of you guys don't. Some of you guys want this. So fine. Sine is O over H. What does that mean? Opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. And then these are the others flipped upside down. You got the idea, right? So what I would do is I would always turn my triangle so that theta was on the bottom. It was like on the x-axis. So that would be y, that would be x, and that would be r. But a lot of people don't do that, and I get it. It's fine. You can do whatever you want. It's a free world of choice here. So they would call this the hypotenuse. And then you can see that the hypotenuse helps make up the angle, right? That there's two sides that make up the angle. Well, one's the hypotenuse. The other one is going to be the adjacent side. Adjacent means next to, so that side next to the angle makes up the angle. And then the one that doesn't help make up the angle is opposite. It's across from it. And so those, that's the definition that we use. You may ask, how did they come up with this? They defined it to be this way. So we're stating a definition. We're saying the sine of an angle is going to be this. We're making that statement. And it has to be a 90-degree triangle. So we'll get to a point where we don't have 90-degree triangles. And that will be a lot more interesting. So it says find the exact value of the 6 trigonometric ratios of the angle theta in the triangle. So I have to go sine of theta, cosine of theta, tangent of theta. Now, some people second hour were saying, do we have to write all of these down? I don't care what you do in your notes. That's up to you. Yes, you do have to do it in your assignment and your test. Not because it's a value, but because I just want to make more work for you. It's my only goal. I just sit back and think to myself, how can I add an extra 10 seconds to their daily work in life? How can I do it? This is one way. Okay, so what's the other side? Five, 13. Well, I guess we better use the Pythagorean theorem. Or x squared plus y squared is r squared. Same thing. 5 squared plus, we'll call this b. B squared is equal to 13 squared. What's 5 squared? 25. 13 squared? 169. Subtract 25. B squared is 144. So B is 12. Everybody see how I got that? That's assuming it's the right triangle. I don't have that button on my on my computer. Okay, so what's sine going to be? You could go ahead and label the sides. You know that this is the hypotenuse, or you could call it r. You know that this is the adjacent side, or you could call it x. And you know that this is the opposite side, or you could call it y. However you want to think about it, it's the same thing. So what's sine going to be? Yep, 5 over 13. Cosine? Good, 12 over 13. Tangent? 5 over 12. Cosecant? Yeah, then everything just flips around. It's easy after that, right? Done and done. Okay, can I tell you something that I really like about this though? Tangent was y over x, right? Think about it. Y over x. Rise over run. So tangent is the same thing as slope, same thing. So then all of a sudden you can rewrite, instead of y equals mx plus b, we could go y equals tangent of theta plus b. I mean, and we'll do all sorts of stuff like that later on. Or we'll actually change theta. So, all right. Did I? Oh, I'm sorry, 5 over 12. Just checking to see if you guys are watching. Saw a few of you start to... What? Just checking to see if you guys are awake. A couple of you getting sleepy eyes. All right, how about that one over there? What do we do? 2 roots of 5. Casey used the Pythagorean theorem. She came up with square root of 20, which reduces to 2 square roots of 5. Very good. Now I have to write them all down. Sine of theta, cosine of theta, tangent theta, cosecant theta, secant theta, and cotangent theta. Now, this one's kind of turned upside down. I know that 2 roots of 5 is going to be the hypotenuse. Tell me, is 4 going to be the opposite side, or is it the adjacent side? It's opposite, because it's opposite the angle. Whereas 2 helps make up the side of the angle, so that would be your adjacent. So what's sine? Four over 2 roots of 5. How do I simplify that? That's like 2 over the square root of 5. Multiply top and bottom by square root of 5, and you get 2 roots of 5 over 5. Cosine 2 over 2 square roots of 5. Or 1 over the square root of 5, which is square root of 5 over 5. So what's tangent? What's tangent? 4 over 2 or 2. Good. So cotangent is 1/2. Now, can I show you a trick so you don't make more work for yourself? For cosecant, you're just going to flip sine, right? Well, instead of flipping, the end one, flip the one before it. So instead of 2 over the square root of 5, you're going to have square root of 5 over 2, right? See? I mean, if it was in the denominator before, now it's going to be in the numerator, right? So like 1 over the square root of 5 will be square root of 5. Cool. Any questions? Flip it over. We're almost done. You guys are so smart. Okay, now we got to figure this out. 9. Is 9 the opposite, the adjacent, or the hypotenuse? It's the opposite. Is x the opposite, the adjacent, or the hypotenuse? Hypotenuse. So what you do is you look at the angle that you're given, and you look at the two sides then, one that you're given, the other one you're trying to find, and you choose which trigonometric ratio you can use in order to solve for the missing side. Now this is from geometry. You guys have seen this before. But do I take the sine of 42, the tangent of 42, or the cosine of 42? Sine, because you have opposite over hypotenuse. So we're going to say that the sine of 42 degrees is equal to the opposite, which is 9, divided by the hypotenuse, which is x. Cross multiply. 9 times 1 is 9. X times sine of 42. In order to solve for that, you'll divide both sides by the sine of 42. So that's what we want to type in our calculator. 9 over the sine of 42. Take all your calculators. And you'll do this a lot. Throughout the rest of the year, you're going to do this a lot. You're going to have to know exactly what to do when. We even do it in calculus. But if you hit mode, you can see that your calculator knows whether it should be working in radians or in degrees. Now, the only time that you have to switch this is if you're going to take the sine, the cosine, or the tangent of something. So if you're going to do a trig operation on a number, then you need to get here. So again, just press mode, and you have radians or degrees. Some other scientific calculators also have gradians. We don't need to worry about that. And instead of radians, you just want to move over to degrees. And I know I'm working in degrees because it has this degree symbol there. There's other times you want to work in radians. And you just look at the problem. If it has a degree symbol, then you want to be working in degrees. If it doesn't, you're working in radians. You got to switch back and forth. Otherwise, you make a lot of mistakes. And you'll be mad at yourself come test time. So I'm working in that, and I go 9 divided by sine of 42. And that should give me my answer, 13.45. Does that make sense that the hypotenuse is longer than the opposite side? Yeah, so you can kind of check it with, what you got. Okay, the next one, sine, cosine, or tangent. If this is my 90-degree angle right here, sine, cosine, or tangent. Good. You can see that they don't give you anything for the opposite. The adjacent is what we're trying to find. 14 is the hypotenuse. That's what we're given. So we can set it up. We can say that the cosine of 63 degrees is equal to x over 14. Cross multiply, x is equal to 14 cosine of 63 degrees. So I just type that in my calculator. You should get about 6.36. Why don't you try that last one on your own? Go for it. It's like watch birds. Okay, what'd you get? About 4.8. Any questions how we got that? This is the 90-degree angle. This is the adjacent side. This is the opposite side. So do we use sine, cosine, or tangent? Tangent involves opposite and adjacent. So we set up tangent of my angle, 27, is equal to the opposite, which is x, divided by 9.4. Cross multiply. X times 1 is x. 9.4 times the tangent 27 is 4.8. Got it? Okay. You do? Some people got an extra sheet, I'm sorry. Don't worry about it. Okay, sketch a triangle that has acute angle theta and find the other 5 trigonometric ratios. We're not going to find all 5, but we're just going to actually sketch a triangle. So sine is 3/7. So what I want to do is opposite will be 3, hypotenuse will be 7. So what I need to do is I need to find out the adjacent. How could I find out the adjacent? Yep, 3 squared plus what? So 9 plus y squared is equal to 49. So y squared equals 40. 2 roots of 10. So that's definitely bigger than 3 is. So it looks like 3 is going to be my smallest side, and that's the opposite side. So I should label theta. Should put a 90-degree angle in there. My opposite side is 3. My hypotenuse is 7. And y is going to be 2 roots of 10. Could you now list off all 5? No. We won't do it because I know you're really good at that. Some of you. All right, now look at this. Secant is 9/10. Well, that would mean, let's see, secant would be the hypotenuse divided by the adjacent. Can the hypotenuse be shorter than the adjacent? No. Mr. Gens wrote a bad problem last year. So secant of 10/9, we'll say. Or secant theta equals 10/9. Let me write that better. So we're going to change the problem. Because this one doesn't work, it would have no solution. Secant theta equals 10/9. Go to work there. Well, now the hypotenuse is 10 and the adjacent side is 9, so I need to calculate the opposite side. So again, I will do 9 squared plus x squared is equal to 10 squared. 81 plus x squared is equal to 100. X squared is 19. X is the square root of 19. So that's the smallest one, isn't it? That's smaller than 9 or 10. And that's going to be my opposite side. So that looks like a sufficient triangle. Now that you're given that triangle, could you find the other 5 if you were asked to? That's because you're super smart. All right, 2 word problems. They go quick. And I'm a great artist. Wait till you see this. A kite is flying. So I'm going to draw my kite. Is there somebody who is a really good artist? You could draw really well. Julia? She doesn't even show up. So it says it's flying at an angle of elevation. So from the ground up is 36 degrees. 500 feet of string is let out. Is that 500 going to be the opposite, the adjacent, or the hypotenuse? Very good. I'm wondering how high it is. How high it is that going to be the opposite or the adjacent? Opposite. Called H for height. Sine, cosine, tangent. Sine of 36 degrees is H over 500. Cross multiply. H is 500 times sine of 36, which is, what, 293? Well, let's be exact. Any question how I got that? Probably put a label on it, shouldn't we? Feet. And the last one, a tree. Trees are my specialty. It's a squirrel hole. It's a gigantic squirrel. It's a rabified squirrel foaming at the mouth. It's a branch. Stop it. All right, there's my tree. It's 10 feet tall. Casts a shadow. There's a shadow. 7.3. It's wondering what is the angle of elevation of the sun to the horizon. So if you would have an angle like this, and there was a sun up here, it's wondering what this angle theta would be. So you can see we've got a triangle, don't we? Sine, cosine, tangent. What? Tangent of theta, which we don't know, is equal to 10 divided by 7.3. What makes this different? You don't know theta. We got to find theta. Well, if I had 5 over 3x is equal to 30, how would you guys solve for that? What would you do to both sides? Multiply by 3/5, because what that would do is it would leave you with only x, right? Well, the whole idea is we want to get to the variable, so we have to do what's referred to as an inverse operation. We've covered this before. Inverse operation for tangent happens to be tangent inverse. So tangent inverse of tangent of theta is equal to tangent inverse of 10 over 7.3. So you don't have to write this out every time. This is just to show you what's happening. If I do tangent inverse of tangent of theta, what do you think I end up with? Theta. Okay, just like over here we end up with just x. Over here we end up with just theta. Tangent inverse undoes the tangent. So now I need to type in tangent inverse. So I go to my calculator. And I go tangent inverse of 10 divided by 7.3. And I get 53.87. What do you think of that? Got it? Here's your assignment. Get caught up on your homework. You had a 3-day weekend. I did my homework over break. Graded Casey's test. Graded Trenton's test. Got my grades updated. Wrote a calculus quiz. Added up an infinite number of rectangles a number of times. Oh, coterminal worksheet. Yes.